I did not think this would ever be physically possible. Look at that. This is a new super resolution technique for videos and video games. So in goes a really coarse pixelated piece of footage and out comes this absolute beauty. And the input is, look, 270p. That is a really low resolution. A
What the
potato can compute
hell?
that. So whenever you see LR, that is the low resolution input. Ours marks the new technique and GT is the ground truth, that is, rendering the true result in a high resolution without any help, which, of course, takes much longer, but is necessary for comparisons. The Eastern Village scene offers some of the best super resolution results that I have ever seen. Goodness! Wow!
And this isn't a simulation. So in the previous video that I had wrote with NVIDIA's order, I'll make sure I leave a card above. It goes into how the physics of it splashing and everything, how it might help just the overall advancements of different things. So he asked the question, what would you use the simulation for? I will make a game. You feel me? That was my first response. It's just crazy to see how it's being translated right now, like one day later. That video was made 3 months ago. This video is probably gonna come out on Christmas. Yeah, Christmas is gonna come out because I just want the game community to be excited. You feel me? So Christmas is gonna come out and overall, what the fuck do you mean? There's a simulation that can make better graphics and games and at higher speed. Like that's awesome, my nigga. What the
It
hell?
is really close to the ground truth, too. And so far, you have seen nothing yet. Look at the medieval dock scene here. That is some kind of joke, right? I mean, just look at the vegetation here. A bunch of pixels. Would you be able to make a drawing pixel by pixel and guess what this exactly should look like if it were in a higher resolution? For me, not a chance. But this new technique, wow! That is stunning.
Nah,
Yes,
yeah,
it still
that's
has trouble with thin structures like this. That is
nah,
the 2-minute paper special, but to think that it can go from this to this sounds like something straight out
out
of
of
a
a
science
movie.
fiction movie.
Yeah.
And I am really hoping that this can one day be the future of gaming. Could we just buy a cheapo video card, render the game at a really low resolution, let this AI do its magic, and off we go? Also, this is all well and good, but how fast or slow is it? If you take an hour to do this per image, that is not very practical, is it? So, how
You know,
long does all this take? Let's have a look together. Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. Well, for a previous method from just 3 years ago took more than 100 milliseconds per frame, which is 10 frames per second just for super resolution. And we haven't even rendered the game, so that is clearly not practical. In fact, it wouldn't fit easily on this chart because the bars would be so long. Wow, that is almost 10x faster than the technique from 3 years ago. That is stunning. But there are other techniques out there, so what about those? Well, if you are looking for a mild 2x, doubling the resolution, the new one blows the doors off. It can do this 82 times per second, easily twice, almost 3 times as fast as some of its competitors from last year. Super good. Now, let's bump it up to 3x. Oh yes, things are getting closer now, but it still comes out ahead, and if we are really demanding, we want to quadruple the input resolution, it takes a tiny bit longer than Fuse SR, a fantastic technique from just a year ago. So, in that case, I wonder if it is worth waiting this much for. Let's have a look together. Yes, the new one is certainly better here and is worth the longer execution time, while other cases are a bit more subjective. Which one do you feel is better? Let me know in the comments below. And now, let's try to resolve this somehow together.
honestly, I don't want to say the new one isn't good. I could see how Fuse SR is like. So this one right here, it looked like there's certain things about this image that's more defined than this one. I'm not gonna lie to you. Like the new technique, it looks like where it's darker here, we couldn't really render that in. But these two did it fine. True Image Infuser. You get what I mean? Or even the one before that. This one, this one you could say is blurry, but it's just not. It just doesn't have definition. You get what I mean? Because right here in the middle area, it's blurry, but it seems like it's not defined. It just correlates with the image. This one is clearly better in this example. I'm not saying it's not. I'm saying I could see how Fuse SR, lastly, kind of just took the lead when it comes to efficiency for 3 times. Because it looks like it could get more specific with that technique or more nuanced. You
Let me know
know,
in the comments below. And now, let's try to
even with the bucket, like the bucket here looks, I'm not gonna say it looks way more defined, but it looks like you can call it like a bucket. This one is a bucket too, but you can call it a game asset. Like these two look like game assets. I could genuinely say this one might be a bucket. I could be wrong. You know, everyone has their own opinion, but it just looks like a lot of definition and a lot of like things going into this rendering right here.
resolve this somehow together. So far, we eyeballed
It's
the
the handle.
results.
Cause look
Now,
at the hand.
let's look
Hold on, look at the handle for this. That one looks like, yeah, it's out of here. This one though, it resembles this one. It's just not as good as this one. You get what I mean? You could just look at the handle. Let's forget about the bottom part.
somehow together. So far, we eyeballed the result together and calculate a score mathematically. What does mathematics think about subjective cases like this? Who wins? Well, did we get an answer? Yes and no, but mostly yes. Let me try to explain. If we just measure the distance between the pixels compared to the true image, the new technique is clearly better. However, this metric does not understand the image, it just measures distances. If you take an image and you darken it a bit or brighten it up, it does not know that it is the same image. Thus, it gives it a poor score. So, they also checked structural similarity that is a bit smarter as it can take into consideration that a darker version of the image is still the same image. If we look at the overall scores, the new technique does not win everywhere all the time, but it wins most of the cases. I am comfortable handing it the win. Also, technically, this new technique is chef's kiss. Why? Well, get this. It uses the Fourier transform, a mathematical technique for breaking down a signal, for instance, a song, like taking the bass guitar out of a song. And it mixes that with deep neural networks, and hence, this is called deep Fourier-based super resolution. Okay, so
All right. This is a great one. And SSR is not it. Fuse SR, like look at the definition. Even here you could see how it's resembled. Right here, maybe the back isn't as like right here, it's not as clear as this part. I ain't gonna lie to you. Like you could see the holes in this box right here. I wanna say it is. Right here, you can see it, but on a grainy level. You know what I mean? Even on all the way to the back, you could see that there's boxes back there, but right here, you could see that there's like things, like maybe that's a dresser or some shit. Maybe something is going on over there in the back corner. The others, it's not. I can't really. That's too grainy. L double I F N S double R. That's just pixelated. But these two right here, you could interchange them at any point. I feel like one method could be used for certain scenes and another method could probably be used for another scene.
what are the limitations? Is it perfect? Clearly not. Thin structures are not great. There are also cases which are highly subjective. This one is a very typical case of over-sharpening versus over-blurring. Pick your poison. Temporal splotches are also present, I believe, a bit less than for the previous technique from a year ago, but it's still there. That is what we are looking for to make this more practical. And finally, a disadvantage that is relatively easy to isolate. That is fog and particle systems. In those cases, you flat out cannot use this super resolution. Not because it theoretically can't, but because it looks at geometric data from something called the G buffer and there is no data for particle systems in there. That is a bit of a bummer, as those can get really costly to simulate, but it is theoretically possible to pull it off. So, just imagine what we will be capable of 2 more papers down the line. That is the first law of papers. For instance, I can imagine that we won't even need the high resolution assets like geometry or textures for a game that we are creating because we will be able to use super resolution so reliably that we simply won't need them anymore. Perhaps this will be like compression, but taken to the extreme. What a time to be alive! And to think that we have amazing papers like this appearing day by day, and scientists giving the description of the technique away for all of us for free. A fantastic scientific contribution.
It's not free. It's just in the tech space. We really have to take advantage of the community. Like this is the only community where you can build and build and build, and it'll all be IoT, like all be infrastructure of technology. You know what I mean? Which just means integration of people. We're building the next tech. We're building the next comic. We're building it. So it's free, but it's not. You got it. With great power comes great responsibility, is what I'll tell you. So if you know how to code, you know how to develop and solve a problem, you have all the tools you need. You do not need ChatGPT or any of these models that's charging you a payment. What you do need is some time to practice, own your skills. You may not be able to get a project done in a specific amount of time. That's okay. Fall on your face. You know what I mean? Because we're on the forefront of technological advancement. So it's your job to keep up.
And a great gift to humanity. Thank you. So, what do you fellow scholars think? Let me know in the comments below. We need new tools for the era of LLMs, and Weights and Biases now has Weave, a lightweight toolkit to confidently iterate on LLM applications. Use traces to debug how data flows through each step of your app, and use evaluations to measure your progress. It is the best. Try it out now at wnb.me/papersllm or click the link in the description below.
What a time to be alive, man. 2 minute papers. I really do love your content, what you bring. Don't leave a comment, you, like, the video. Thanks for the paper, fellow scholar. Well, my spelling is not the best. Oh, and Grammarly is gonna do that to me. Scholar. Thank you. I did not want to put the O. I did not. I want to put the O. All right, y'all. Thank y'all for tuning in. What y'all think y'all will use this simulation for? Please leave it in the comment below. I'll make sure to link the other video, which will talk about NVIDIA's water physics. That's another one to get into because they're the ones that initialized this whole groundbreaking journey for physics. And if you know physics, it's always fuck you, physics.